To start this lesson off, we have a simple sphere and a plane that we are currently rendering in Blender. We're also going to look at the same scene in Vortals. Now, Vortals is a real-time system, whereas what you're looking at in Blender is a rendered system. The system is slowly building a picture here of a rendered result. Both of these currently have a bit of a gotcha when you start lighting a scene. If I turn my one and only light in the scene off, the scene is still lit. In Blender, the background environment contributes to your lighting. And so even with zero lights in the scene, you currently have lighting enabled. Now this is something that is common to most 3D packages. So if I started trying to build the lighting in my scene, I've already got lights in here, and that's affecting the end result. So if we come to Vortal, you can see that in this scene I have absolutely no lights. There's no light in the scene, and yet the ball is currently lit. And so Vortals also has default lighting. Pretty much every 3D package will have default lighting setups so that when you first load in a 3D model, you can actually see it. But the problem is if you then start trying to light your scene, this lighting will start to contribute and you won't be able to control the scene like you wanted. So what I'm going to do is I'm going to turn off default lighting. And you'll see now the whole system has gone gray. And that's because we also have a background that's contributing to the lighting on this object. So I'm going to add a new background. And now the system has no light, and we're ready to begin lighting this scene. Now we need to do the same thing in Blender, and so I'm just going to change the world background lighting to black. So now I'm going to turn this light back on. And this light is a point light. And a point light means that all of the light is coming from an infinitesimally small point right in the middle of this dot. And you can see that because it all comes from a very tiny point and moves out, you have a really, really sharp shadow from this. Now, if you look at your arm on your table as you're working, or you look at any shadow around you, you'll probably find that sharp shadows are not actually that common at all. Now, if we go to Vortals and we do the same thing, we add a point light, you'll see pretty much the same result. So in the short term, a real-time system and the rendered system are looking pretty similar. But as I say, this sharp shadow, it's not that common in lighting. And so one of the things you can do is you can change this from being a point light to coming from an area. So if you look at the options here, we can change the size from 0 meters to whatever we want. So let's turn it to a 1 meter. What this means is that all of the light is coming from a meter sphere around. And that has the effect of creating this blurry shadow boundary. And again, you'll find this is much more common in the real world. You'll see these shadows far more often than you will seeing a sharp shadow. Now, if we go to Vortals, you'll notice there's no option to do that. And that's because this is a real-time system. One of the things about games is that they've worked out many little tricks to trick you into thinking that these things are possible. But as a general rule, this is the base system that's running, and I'm trying to give you the fundamentals of how the base system is operating, not the great tricks that have been developed to hide all the problems of real-time lighting and rendering. A real-time system cannot do what Blender is doing here and creating this soft shadow. And you can see, in fact, once I've created the soft shadow, how long it actually takes Blender to create that solution. So up here on the top left, you can see it's still trying to render the scene. It's still trying to work out what this looks like. And so for a real-time system, that's far too slow. In Blender, you also have this idea called an area light. This is quite similar to the point light with the size. The difference being that this is now a rectangle. And you can see it gives you different types of control over what the softness of the shadow is doing. Now, a spotlight works very similarly to a point light. The only difference being that you have a cone of visibility of the light, and that's determined by the angle of that spotlight. It is, however, bound by the same rules as the point light. So here we have a system where all of the light is coming from a single point. And you can see that there are very, very hard shadows everywhere. And that's because it's all emanating from a single point. But we can make it an area light. So now this is a 60 centimeter light, and you can see that all of the shadows have now become a lot softer. And it doesn't matter if I've got a wide angle or a small angle, the softness of the light remains. Now this is also available in Vortals. In real-time systems, you can still have these spotlights, but again, you can see there is a hard shadow that's created. Now the final type of light that's available is what's known as a direct light, or in Blender it's called a sun light. And what that means is all of the rays of the light are all coming from one direction. So it's not from one point, they're all coming from this distant direction. Now in Blender's case, it's trying to emulate the sun, and so it's giving you soft boundaries regardless. In Vortal's case, this is a direct light, and all of the rays of the light are heading in one direction. So it doesn't matter where I put this, you'll see that the lighting solution doesn't change regardless of the position of this light. However, if I rotate the light, you'll see there's a dramatic change. So one of the things that you'll find about light is that light bounces. It doesn't just hit a surface and stop. The light will actually bounce. So while we're looking at this solution, we'll notice that there's a light here, and then this side is very, very dark. But if the light were to bounce, let's say the light bounces, comes from the light, comes down here, and hits somewhere around this little red line here, you would expect it to bounce up. And then it might hit this area in the dark. And so render packages like Blender do have the ability to bounce a light. And so now I've got one bounce in this scene happening. And you can see it has a dramatic effect on what this system looks like, because now the light has hit this white area, this gray, sort of gray-white plane, and it's bouncing up into the back of the ball, which previously had been shadowed. So now let's increase this light power so that it's super bright. And so now you're seeing that this whole underside of the ball is actually getting quite bright. But you'll see down here, this shadow is still very, very dark, which looks a bit weird now because you've got a very bright light that's very bright surface that's facing the light. You've got a very bright underside that is kind of getting lit by this area here, but then this is absolutely pure dark. And that's because we've only got one bounce. So the light is coming down through here, it bounces and it hits this ball here, and then it stops. The computer says, all right, you've bounced once, that's enough. But we could add a second bounce. And so now you're seeing the light is coming down, it's hitting this, it's bouncing up on the backside here, and then it's starting to bounce onto the darkened area of the shadows. And the more bounces we have, the more effect that's going to have. And the more power the light has, the more you're going to see that take effect as well. So this is a very important idea, that the fact that light bounces around actually is vital to how a system is lit. So let's have a look again without any bounces. And now you can see that this system looks far less real than a system with two bounces, because now the light is actually traveling and bouncing around and actually creating what would actually be happening in the real world. Now you might look at the scene and think, well, of course I want to bounce. I want 10 bounces because it's better when things are bouncing correctly, because in real life, the rays will just keep on bouncing until they hit our eyes. But the problem with that is that computers are finite. They have limited rendering capability. And the more bounces you have, the longer it will take to render. And there's just a point where you might want to have more bounces, you might want to have more detail, but you simply can't afford your rendering. It'll take too long. And so this is the problem that we face as CG artists, is that we're all working with limited rendering power, limited computing power. Even if you've got a supercomputer, you're still limited by all of these factors. There is one final type of lighting that applies to both gaming and rendering systems. So we're actually still looking at the system with a wall, a floor, and a bounced light. And on the wall, I've applied a principled BSDF shader. And again, in any 3D package, this might be different. But the reason why I've applied this one is it has an emission channel. So if I change the emission channel from black to pretty much anything else, you'll start to see this object actually emit light. So now this is an object that's emitting rather than actually creating a light. The object itself emits. And we can actually use maps rather than just a single color. We can use an image texture to create this. So here I've just added a wild and crazy texture to it, and you can see that it's actually creating light based on the color of the texture. Now the one thing about this is that it's a very expensive technique. So again, when you're trying to render a scene, and if you have lots and lots of objects in the scene, and it's a complex scene and you want to start rendering, this can be a very inefficient way of doing it. So you don't always want to do it. However, this is a technique that actually plays a part in gaming. Now in gaming, it works very differently. It doesn't actually emit light like this into the scene, but what it does is it gives you access to camera effects. So we're going to explore that now in Vortals. So in this scene in Vortals, we have a number of lights around the scene. Some that have been set up outside the windows, some that have been set up around these outside lamps. And if we look at the lamps and we go to the advanced options of the shader, you'll notice that there is an emission image in the advanced options of this shader. And these lamps have an emission channel that has been attached. And so do the windows. These textures are not just color textures, they also have an emission channel. Now, if we go to our light, if we go to our camera, the camera has an effect called bloom. And this bloom is linked to the emission channel. So if I increase the bloom, you'll start to see all the objects that have an emission channel are starting to bloom. They have a glow that's coming out, as if they've been lit. Now, if you look carefully at the scene, you'll notice that the lighting itself doesn't change as the bloom does. So there's no more shadows, the shadows aren't moving, the lighting on the ground isn't getting brighter or darker. All that's happening is the objects that have an emission channel are now contributing to the bloom. And you can see it has a dramatic effect on making the scene feel like it's brightly lit.